Hello dear students, welcome back. In the today's class I am going to start a new chapter, inverse trigonometric functions. Okay, so this chapter carries 8 marks in your annual examination, 1 question per 1 mark, 2 question of 2 marks, means 4 marks, 1 question for 3 mark. Okay, 1 plus 4 plus 3, so you will get a totally 8 marks in this chapter. Okay, so let us discuss about the inverse trigonometric functions. Okay, so dear students, already we know the concept of inverse functions and trigonometric functions. Okay, so by using the concept of inverse function, and as we studied trigonometric functions and their graphs with their properties in the first PU classes, now let us study about the inverse trigonometric functions. Okay, so to define a inverse, as we know, as we studied in the relation and function chapter, for the existence of inverse, the function should be bisective, means it should be 1 1 and on 2. Okay, that is, for example, a function f from x to y is said to be invertible if it is bisective, that is 1 1 and on 2, and inverse of f is defined by f inverse from y to x. Okay, so this is, here we will get f of x equal to y for all x belongs to x. Okay, here for all y belongs to y, there exists x belongs to x such that f inverse of y equal to the x. So this is the invertible function definition. Okay, so to exist inverse of a function, the function should be bisective, means it should be 1 1 and on 2. Okay, and already we know f composition, f inverse composition, f of x equal to the x for all x belongs to the capital X, and f composition, f inverse of y equal to the y for all y belongs to the capital Y. Okay, so these are the basics about the invertible functions. Okay, then come to the trigonometric functions. Okay, as we know, all trigonometric functions are periodic functions. Okay, and this inverse trigonometry functions are very important. They have the wide applications in science and engineering and technology. Okay, so for that, to exist the inverse of a trigonometric function, we will restrict their domain and range. Okay, so come to the inverse trigonometry, that is, first let us know about the trigonometric functions briefly. So see this is a sine function. So sine function is defined from set of real numbers to the minus 1 comma 1 with the domain R and range minus 1 comma 1. Maximum value of sine function is 1 and minimum value of sine function is minus 1. And we know all trigonometric functions are periodic functions. That's why we know periodic functions are not invertible, because they are not 1 1 and on 2. Therefore, to exist the inverse of trigonometric functions, we will restrict their domain and range to make it bisective. To make them bisective, we will restrict their domain and range. So see here, this is the graph of the sine function. Okay, 0, pi by 2, pi, 3 pi by 2, 2 pi, and minus pi by 2, minus pi, 3 minus 3 pi by 2, 2 pi. So as per the definition of bijective function, that is 1 1 and on 2, if I drawn a line above the x-axis parallel to x-axis, it meets more than one point of the graph sine, therefore it is not a 1 1. Similarly, below the x-axis it meets more than one point, therefore it is not a on-to function, therefore it is not a bijective. However, by restricting their domain and range, so see here its domain is R, means all the values on the x-axis R. Okay, so see here now, sine x equal to 2, cos x equal to 2 does not exist, because so maximum value of sine and cos are 1 only, therefore so these doesn't exist. Therefore now I will define sine inverse. So first I will draw the graph of sine inverse. Okay, before that, see, sine will be invertible in this range, this minus pi by 2 to the pi by 2 and pi by 2 to the 3 pi by 2, only this colored region from here to the here. Graph, you observe the graph from here to the here, and this minus 3 pi by 2 the pi by minus pi by 2. So these are the reason where the sine function will become 1 1 and on 2. See, in this region only, if I draw the line above the x-axis and below the x-axis, so it meets only one point, therefore the function will become invertible. Okay, so these are the restricted domains, restricted domains of the sine function. This is minus pi by 2 to the pi by 2, then minus 3 pi by 2 to the pi by 2, then this pi by 2 to the 3 pi by 2, and so on. We can define many more. Okay, so in these regions only it will become invertible. Therefore, so this is the sine function from R to the minus pi by 2 minus 1 comma 1. So sine inverse, so it will become invertible if here also so on minus 3 pi by 2 to the minus pi by 2 or minus pi by 2 to the pi by 2, or one more is there, I draw in here, pi by 2 to the 3 pi by 2 to the minus 1 comma 1, and here also so on. So these are the domains. Okay, sine inverse is defined here. Okay, so in this sine, basically sine will, I will define this like this, made intervals, means closed intervals, this different ranges. So if I considered any one among this in the domain, then sine will become invertible, Okay, so this is a one reason, this is second reason, this is third reason. Okay, let us see the definition of sine inverse. So sine inverse is defined from minus 1 comma 1 to the minus 1 comma 1 to the any one among these. Okay, I will take minus pi by 2 to the pi by 2, minus pi by 2 to the pi by 2. So this is the definition of sine inverse. Okay, now so let us see the graph of sine inverse function, how it will define. just inverse of a sine graph, sine inverse function graph will be obtained by interchanging its x-axis and y-axis. So now I will make this as a y-axis and this as a x-axis. Okay, let us see here. So I have taken the values 1 and minus 1 on the y-axis. I will take here on the x-axis because the input is minus 1 comma 1, minus 1 1. So this is x, this is y. What I did here, just I am interchanging the x and y-axis values. That is, suppose this is order pair. See here, this is the point pi by 2 comma 1, pi by 2 comma 1 in the sine graph basically. Then this point will become reverse in the sine inverse graph, that is 1 comma pi by 2. Okay, so let us see. This is pi by 2, pi, 3 pi by 2, 2 pi. Okay, then minus pi by 2, then minus pi, minus 3 pi by 2, then minus 2 pi. So what is the value of pi by 2, sine pi by 2? That is 1. Okay, it will come here. So pi is 0. This is the graph. So see here carefully. Okay, so next it will move like this. It is okay, point, this is the point, and extend this side also. Okay, this is pi point. So see here now, this point is 1 comma pi by 2, 1 comma pi by 2. So see here, this is the order pair pi by 2 comma 1. In the reverse, if I take inverse, it will become 1 comma pi by 2. This is the graph of the sine inverse function. So in this, I will take in this the region. See here, from here to here. Okay, one region, one more region from here to the here, and one more region from this to this. Okay, so these are all the possible, and so many more we will get if we extended the graph. Okay, so basically these are the possible ranges, that is 3 pi by 2 to the pi by 2, pi by 2 to the minus pi by 2, or else minus pi by 2 to the pi by 2. Okay, so these are the possible graphs, the possible ranges of the inverse function. In this ranges, so this minus pi by 2 to the pi by 2, minus pi by 2 to the pi by 2 is called the principal value branch. We will call this as a principal value branch of the sine inverse function. Okay, so this region is called as the principal value branch. So and these regions have the other names. Okay, so this is called as the principal value. This is very important for 1 marks. They will ask a question, write the principal value branch of sine inverse. In that time you should write minus pi by 2 to the pi by 2, closed interval minus pi by 2 to the pi by 2. So this is about the sine inverse, how it will be exist. So simply it will exist. So now see, you can write any line above and below the x-axis. So it will meet only one point of the graph, therefore it will become invertible, and this is the graph of sine inverse function. So this is called as this point minus pi by 2 to the pi by 2 principal value branch. Principal value branch of sine inverse, principal value branch of sine inverse. Okay. So and other reasons have the different names. So see one property of the sine function, I will draw here simply in a very simple diagram. It will possesses a mirror image. So mirror image with respect to a straight line y equal to x, y equal to x. So this is the graph. I will draw one straight line. So this straight line is y is equal to ex, passes through the center. Okay. Now just draw the graph of sine function. This is the graph of sine function, right? And now in this graph only draw the graph of sine inverse function. Okay. This is the graph of sine inverse function. Okay. This is the graph of sine inverse function. See here now, this line passes through the center, straight line y equal to x passes through the center, makes a mirror image. So see above the straight line and below the straight line. Okay. So you will get a mirror image of this here. Okay. When you will face the mirror, you will get your face, exact face. So like this. So this is the mirror image of this with respect to the straight line y is equal to the x. When we will combine the sine function graph and its inverse, and by seeing the both graph through the straight line y equal to x, so it looks like the mirror image of this. Both are the mirror images, mirror image of this or this. Okay. So this is about the sine inverse graph, how it will be exist. And see here now some notes. Sine of sine inverse x equal to the x, because sine and its inverse will get cancels. Sine of sine inverse equal to x if so x is in between or equal to the minus 1. This is, and one more, sine inverse of sine x equal to x, sine inverse of sine x equal to x, this is possible if minus pi by 2 to the x, this is pi by 2. Why this is? See here, inverse function, so its input is minus 1 comma 1, so x should be in between 1 comma 1. Then just sine function, okay, its input is, sine function input is r, set of real numbers, or else we can take any interval in this, that is minus pi by 2 to 5 by 2. I took care, so that's why. So in this, if you wrote sine inverse in the bracket, take the domain of sine inverse to write the value of x. If you write the sine x in the bracket, take the value of sine function domain, that is minus pi by 2 to the 5 by 2. It is principal value of the sine inverse in this. Okay. So keep remember this. This is also very important. And one more third note, if y equal to sine inverse, if y equal to sine inverse x, then we can write it as a sine y equal to the x. So this sine inverse will come to this side, it will become sine y is equal to the x. And some more important notes: sine inverse is not equal to the sine whole inverse, right? This is not equal to the sine whole inverse. Okay, this is very important because this sine bracket inverse will equal to the 1 by sine always. So this is different than this. Sine inverse is different than sine bracket inverse. Okay, so let's see the some problems of this sine function. Okay, move to the problems of sine inverse function. Very simple basic problems. So inverse sine function. And one more thing, it is also called as a arc sine function. Arc sine function. So this inverse sine function is also called as the arc sine function. Okay, see the problem. Example A: sine inverse of 1 by root 2 is equal to the question mark. Okay, B: sine inverse of root 3 by 2 is equal to the, we have to find. So see here students, we know what is the value of sine pi by 4, that is sine 45, that is sine 5 by 4 is 1 by root 2. See here, sine pi by 4 is equal to the 1 by root 2, right? So see the property number, this 3, y equal to sine inverse x, then sine y equal to the x, or we can write in a both way. Suppose sine y equal to x ಇದ್ದಾಗ ಏನು ಬರಿಬೋದ್ರಿ, y equal to sine inverse x. ಈ ಸೈನ್ ಆ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿ sine inverse x ಬರಿಬೋದು. ನೋಡಿ ಶಿಫ್ಟ್ ಮಾಡ್ತೀನಿ ನಾ ಇವಾಗ. pi by 4 sine inverse of 1 by root 2. Okay, dear students, in the first year classes we have written sine pi by 4, sine 1 by 2, sine 1, like this. Now we will write the value sine inverse of 1 by 2, 1 by 3, because its domain is minus 1 to the 1. So input is always in between minus 1 and 1 or equal to minus 1 and 1. So the values are, input values are always numericals, not in terms of pi. Okay, so this is equal to the pi divided by 4, then come to sine inverse of root 3 by 2. So we know sine pi by 6 equal to the root 3 by 2. Okay, so keep pi by 6 here, take sine to this side, it will become sine inverse root 3 by 2. So sine inverse of root 3 by 2 equal to pi divided by 6, right? Next, C, sine inverse of 1 by 2. So when it will be 1 by 2, it is equal to the, this is pi by 3, sorry, pi by 3, pi by 3. So this is equal to pi by 6. Okay. D, sine inverse of 1 equal to the, so this is what, when it will be 1, equal to the 90, sine 90 is 1, therefore sine inverse of 1 is 90, that is pi by 2. Next, E, sine inverse of minus 1. So come now here, minus 1, sine of minus pi or sine inverse of minus pi by 2 is equal to the sine of minus theta equal to the minus sine theta. Okay, sine pi by 2 is minus 1. Okay, therefore sine take sine to this side, minus pi by 2 equal to the sine inverse of minus 1, sine inverse of minus 1. So what is the value of sine inverse of minus 1? Minus pi divided by 2. Okay, then if see sine inverse of minus 1 by 2. So as we know, sine of minus theta is minus sine theta. So and sine have the value 1 by 2 in pi by 6. Okay, this is minus pi by 6. Sine inverse of minus root 3 by 2. Sine inverse of root 3 by 2 is pi by 3. Sine inverse of minus root 3 by 2 is minus pi divided by 3. Okay, then lastly h, sine inverse of root 3 minus 1 divided by 2 root 2. So this is equal to the, see here, we know this value when sine is equal to the 15 degree, that is sine 15 degree or sine 15 degree in terms of phi, pi divided by 12. This is equal to the root 3 minus 1 divided by 2 root 2. Okay, so pi by 12 equal to the sine inverse of root 3 minus 1 divided by 2 root 2. So this is equal to the pi divided by 12, 15 degree. Okay, so these are the simple, very basic problems regarding the sine functions. Dear students, this is a very important chapter for higher studies also, and it has a very good applications in the science and technology and engineerings. Okay, so I will continue the remaining inverse trigonometric functions, that is cosine, tangent, cotangent, sec and cosecant in the next class. Okay, thank you.